I saw this problem the other day on my For You page, and some of the comments suggested that squaring both sides of the equation would be easier than the approach Carrie took. Now, technically, this approach does work, but there are a few misconceptions I saw in the comments that are really common for students. For example, some students do this. They see a bunch of square roots, so their first thought is to just square everything and get rid of them. But the problem is that when we do this, we aren't actually doing the same thing to both sides. For example, when we add a number to both sides, we don't add it to each individual term. We add it to the entire left-hand side and the entire right-hand side to balance the equation. Now, when we multiply both sides of an equation by a number, we do end up multiplying each individual term, but that's only because of something called the distributive property. So the question is, can we do a similar thing here by squaring both sides and then distributing the square? The answer is no, but this is such a common misconception that it has a name and its own Wikipedia page. It's called the freshman's dream. It's so tempting for students to distribute an exponent because they're so used to doing this with multiplication. But this isn't mathematically valid. Squaring a number means that it's multiplied by itself. So if we apply the distributive property, we can actually show that a plus b squared equals a squared plus 2ab plus b squared, which is not the same as just a squared plus b squared. So can squaring both sides of this equation work as a strategy for solving it? Well, technically yes, but it's really inefficient. We have to square both sides, isolate the remaining radical term, and then square both sides again. And the result is a quadratic equation with two solutions, one of which satisfies the original equation and the other that doesn't, which is called an extraneous solution. So honestly, the method that Carrie showed in his video is probably the most efficient. He subtracted the square root of 2 from both sides and combined the radicals, and he did not combine them as the square root of 6. That would be another really common mistake. Instead, he rewrote the square root of 8 as 2 times the square root of 2 so that he could combine them as just the square root of 2. Then he finished by squaring both sides to get a final answer of 2.